Alright, so here now we are gonna study about the merge sort algorithm. Okay, ah, so I was asking cursor whether it can generate videos as well. Yeah, it cannot. So anyway, let's start a new chat in case we need it. But anyway, the merge sort. So what is merge sort? Let me tell you. This is a kind of divide and conquer algorithm. Okay, that divides the array into two halves, recursively sorts them, and merges them back together in a sorted order. Okay, so how can you remember what merge sort is? It is a divide and conquer algorithm, divides array into two halves, recursively sorts each half, and then merges the sorted halves. Alright, this is how you can remember. Now, like, what are the steps? So, first, split the array into two halves. Alright, now, recursively sort each half and merge the two halves in a single sorted array. Okay, these are the steps. So, what about the time complexity? In the worst case, it is O of n log n, and that is the thing we will consider. And average and best case are also O n log n only. So we will always consider the worst case because you have to handle the worst of the worst scenario. You want to deliver the perfect results. That's why. And the space complexity is O n because you know some auxiliary space is required for merging, and you will know when we will implement that function. Okay, so this is quite efficient for large data sets, and this is a very stable sorting algorithm, unlike those bubble sort, insertion sort, selection sort, n square algorithms. Anyway, so let's implement our function. Okay, function merge sort, and yeah, like this we got this. And what we are gonna do is that, okay, if less than equals to 1, return that only. Now the middle equals to maths.floor. Alright, we will get the middle index. Basically we will get the left index, we will get the right index. Okay, now return this merge. But what is this merge? We will implement the merge function. So the left and the right. Alright, now we will store a result. Now what we are going to do is that I will create const, not const, that I equals to 0, j equals to 0. Alright, and what did we do just now? If I is less than left dot length and j is less than right dot length. Okay. So left half and the right half of the array, when I has not exceeded the first one, j has not exceeded the second one, we will check if the current index of left is less than the current index of the right, then we will push the left one and increment this I. Otherwise, we will increment j and we will be pushing the right one. Why? Because the right will be less or equal to. Okay, if equal to, then also you need to push this one only. Now what you will do is that result.concat. Okay, result.concat this. So this line, why we are doing this? Why we are doing this? So our beloved AI says, because we need to add the remaining elements to the result. Okay, so see, you already added the elements here, right? But now what happens is that some elements will still be remaining. Okay, because you kept incrementing I. Now I reached the length, but J did not reach. What about that? Or J reached, I did not reach. What about that? That's why we are concatenating the remaining elements to the array. Alright, like this. Now what we are gonna do is that we are gonna use this function here. So merge sort left and merge sort right. Continuous recursion is being used. You know, this here it will split into half. Alright, this left will go, left will again get split into two halves, and those two halves, again will get split, then again will get split unless this base case is satisfied. And when this base case is satisfied, you know we deliver the result. Okay, like this. Let me add a breakpoint so that you can better understand. Alright, console.log left and right, and uh, okay, this is already so okay, we are already like printing the array. Yeah, no worries. So we will be running this with our debugger. Run and debug. Alright, I was like, should we run this? Hmm. Now our middle is 3 here because 1, 2, 3, 4, 5, 6, 7. Okay. So it could be 4, it could be 3, but since we are using math.floor, the middle is 3. Okay. Now we got left, we got right. So see this left half and this right half. Alright. Left half and this right half. Now the magic is gonna happen. Ding dong. You got to this. Okay, merge sort left. Again split and split. The base case is satisfied. Array.length equals to 1. The base case is satisfied. Right. The return value, okay, 25, 34, 64. Now, again, 12, 22, 11, 90. These ones, because you are going from right side, 12, 22, and now 11, 90, 11 and 90. Now you will get this return value. So that was sorted. and that is how you got this. Okay, 11, 12, 22, 25, 34, 64, 90. So you saw what happened, right? It recursively called first left, 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 and then right, 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 and right. It kept splitting, it kept merging, and that is how you are gonna implement the merge sort to sort your array using the recursion and this divide and conquer algorithm using these two pointers, you know, like this. So this is it in our merge sort video, and the next one that we are going to implement is the quick sort. So see you in the next video. Thank you.